Okay, so this is a part 2 to graphing some transformations. So in this video we're going to look at an example and we're going to look at all the different ways we can move a function about. So I've got a very general function here. We haven't been actually given what this function is, but we've been told some points and some intercepts, and so we know 4 different points called A, B, C and D. So we have that the y-intercept is 2, we have 2 x-intercepts, 1 and 6, and we also have a turning point. So this is C and this is 4, 4. So we're going to look at some transformations and we're going to look specifically at what happens to these points and the shape of the graph. So firstly, I've got the transformation f of x plus 1. So we are replacing x by x plus 1. Now if we do this, we actually shift the whole function to the left by a factor of 1. So we are shifting by minus 1. So let me just write here to make it clear. Shift by minus 1 to left, or just by 1, by a factor of 1 to the left. So this is what this function is going to do. So let's first sketch out the shape of the graph, and then we can worry about what happens to the coordinates. We need to note that the first x-intercept is 1, so this is going to be shifted to 0. So we're going to get something that looks like this. It's going to cross the origin and then come up and then back down. So already we know that this x-intercept has been shifted to the left by 1, so this has gone to 0. So this is what B looks like now. And then D is very simple as well. We just shift it to the left by 1, so subtract off 1 and we get 5. So we don't actually know what the y-intercept is here, so we don't really care about what A is. A still has height 2, but it's now been shifted to the left by 1, so we can still write it here if you want. This is what A looks like, minus 1, 2. And then C, this turning point, all that's changed is that the x value has gone down by 1. So we now have 3 and 4. So this is kind of all the information that's been preserved from this transformation. All we've done is shifted it to the left by 1. So we're going to look at a few more examples. Let me clear up some space first. Okay, so now we're going to do a different transformation. This time we are going to do f of x minus 4. So we want to look, have a look at what this function looks like under this transformation. Let me draw out the axes. We have x-axis and y-axis. And now you need to remember that doing subtracting a constant off after the function, this has an effect of shifting the whole function down by that constant. So we are shift down by 4, by a factor of 4. This is what just subtracting a constant does. So now we need to take 4 off all the y components of these points. So first off, observe that C has coordinate 4, 4. So if we subtract 4 off the y coordinate, this is going to be 0. So what we're going to get, we're going to get something that looks like this. It's going to come down here and then come up and just touch the x-axis and then go to negative infinity. So as we were saying, the point C now has coordinates 4, 0. So we just subtracted 4 off the y coordinate. And then B, so this is point B. Well, the x coordinate hasn't changed, so we can just write 1 here. But we have subtracted 4 off the y coordinate. So this is now 1 minus 4. And then the A, so this point here is A, the y-intercept. Now we subtracted 4 of it, so this is minus 2. It isn't drawn very to scale. That's not that important. We're just interested about the numbers. And then the last point that we're concerned about is D. So the second x-intercept. So now it's not an x-intercept, but it is still horizontal with B. So the x-coordinate is going to be 6 still, and the y-coordinate is going to be minus 4 now. So these are the 4 points of the original function under this transformation. All we've done is shifted everything down by a factor of 4. For our next transformation, we are going to look at f of 2 times x. So the 2 is inside the brackets. So let's look at what this looks like. X-axis and y-axis. So now by multiplying the input by a factor of 2, what we are doing is we are squeezing in the horizontal direction, or you can think about it as stretching out by a factor of 1 divided by that constant. So we can write here stretch in x direction by factor of a half. Or you can think about this as a squeeze by a factor of a half. It means the same thing. So now we're interested in what this graph is going to look like if we kind of squeeze everything towards the y-axis by a factor of 2. So everything, all the information vertically, that doesn't change. It's just that the x-coordinates get squished towards the y-axis. So the shape's actually going to be exactly the same, just slightly closer to the y-axis. And then we need to work out what... Oh, I haven't drawn this very well. Let me redraw that, sorry. Okay, so we've got our x's, and we want to squeeze this. So we're still going to get the y-intercept. That doesn't change. We're going to come down like this, up, and then down. So the shape of the graph is essentially the same, just a bit closer to the y-axis. So all the information about the vertical direction, that doesn't change. So the y-intercept, that is still 2. We haven't changed anything because it's on the y-axis. And then the first root, this is b. We've squished everything by a factor of a half, a factor of 2, so we are dividing all the x components by 2. So now this becomes a half. And then similarly for d, the second root, we are dividing everything by 2, so this becomes 3. So you can see that we've kind of squished everything closer to the y-axis. And then for the last point, we want to know what c now is. So the y component stays exactly the same. This stays 4. But the x component, we have to divide this by 2. So c is now in position 2, 4. So you can see under this transformation, the vertical information hasn't changed. We've just squished everything towards the vertical axis. Okay, for our next transformation, we're going to do 3 times f of x. So the constant is now outside the function, and we want to know what this looks like. So we have x and y-axis, and what this has the effect of doing is we are now stretching, but in the y direction, in the vertical. We are pulling everything up and down. So let's write stretch in y direction by a factor of 3. Right, so all the information concerning the x components, that doesn't change. It's just only the y components that become bigger. So the shape of the graph is still going to be exactly the same. So it's going to come down here, have a y-intercept, turning point here, and another turning point here. Then it goes off to minus infinity. So now all the x information, that doesn't change. So the coordinates of b don't change. Anything on the x-axis doesn't change. So d also stays as 6. It's only the points a and c that now are going to change. This is the point a. And now we've stretched everything in the vertical axis by 3. So we have to multiply 2 by 3, which gives us 6. This isn't drawn very to scale, but you kind of get an idea of what the numbers are. And then we also want to know what the value of c is. So the x component stays exactly the same. That doesn't change. It's only the y component that we have to multiply by 3. So that becomes 12 now. 4 times 3. That's the new y component of c. So the shape of the graph is essentially the same. It's just that the numbers of the y coordinates, they all get boosted. We are shifting everything up and down. We're stretching it out. For our penultimate transformation, we're going to do a reflection, and we're going to look at f of minus x. So we want to look, see what this function looks like under this transformation. And if you remember, this is a reflection. It's a reflection in the y, so over the y-axis. So let me just write this down. Reflection across the y-axis. Because you can think of, if you put positive values of x, this is now going to correspond to negative values of x. And if you input negative values of x, this is going to correspond to positive values of x. So the function is going to get reflected. So now this is going to be a bit more of a complicated transformation. We have to think about what is the function going to look like if we move everything on the right to the left and everything on the left to the right. So we're going to get two turning points, 2 roots here now. on the left hand side, and the y-intercept doesn't change. So the function is going to look something like this. We're going to have the turning point coming up here and then coming back up through the y-axis to positive infinity. So this is the reflection across the y-intercept, the y-axis. So now we want to know what are the values of these new coordinates. So we need to note that everything in the y direction hasn't changed. It's only the x direction that we've just put a minus in front of. So now this point is A and this is -1. We're just putting a minus. Oh, that should be B, sorry. So this point is B, and we are just putting a minus in front of the x coordinate. And similarly for D, this becomes -6. And then the point A doesn't change. It's still 2. Because it's on the y-axis, the x coordinate doesn't change. It's still 0. And then finally, we want to know what the value of C is, the coordinate. The y component stays exactly the same. It's just that the x coordinate, we have to put a minus in front of it. So this becomes -4, 4. So this is kind of what it looks like. We've just reflected across the y-axis. And I've got one more transformation, one last one we're going to look at. We're going to do minus f of x. So now the minus is in front. We want to see what this looks like. X and y-axis here. So this is another reflection, but this time instead of reflecting over the y-axis, we're actually reflecting over the x-axis. You can think of having the output y, but now whenever we get the output, we are putting a negative sign in front of it. So this just, we just literally put it down here below the x-axis, and it has the same effect for below the x-axis. So this is a reflection about the x-axis. So now I need to sketch this, what it would look like if we would put a mirror here and see what the reflection looks like. So only the y information is going to change. So we're going to get the y-intercept down here. The roots don't change, they stay as they are. But this turning point is going to be down here now. So we're going to get something looking a bit like this. It's going to come down, up here, then turn on the axis, have another turning point here, and then it's going to go upwards this time towards positive infinity. So now the coordinate A, this has been reflected across the x-axis, so we just put a negative sign in front of it, which means the value is now -2. And then the roots B and D, they don't change, right? Because they're on the x-axis. So this stays as 1 and 6. And then lastly, we want to know the coordinates of C. And all we've done is we reflected on the x-axis, so the y component, that has to put a negative sign in front of it. So now C has the coordinates 4 and -4. And this is all the information we want to know about. So we get to see in this case, putting a minus in front of the function just reflects it on the x-axis. So hopefully through this video you've gained a bit more intuition about what all the transformations do, what they look like, and how to apply them. So there you go.